Okay, Assalamualaikum and good morning, everyone.
Sir.
Good morning, sir.
Morning, sir.
Okay, so for today, we will cover lecture 1A and also some part of lecture 1B regarding the tutorial on MATLAB. Okay, so lecture 1A is about the introduction to computational modeling in biomechanics. Okay, so at the end of this lecture, students will be able to understand the concept of computational modeling and its application in bioengineering and understand the modeling processes involved in bioengineering. So I hope you already taken finite element method, and in finite element method, you already learned a little bit about how to model something, okay? Model a 3D geometry, which involve meshing, setting boundary conditions, and so on. Okay, it basically the same thing, but it is more towards the application in bioengineering. Okay, so let's define what is modeling. So modeling is defined as the formulation of a mathematical representation of a physical system. So for example, let's say the simplest mathematical model is Newton's law. For example, like when Newton realized that there's a gravitational force exists in the world when an apple falls down onto his head, then he tries to model how the force related to the gravity, which is F equals ma or mg. So that's basically a modeling, okay, a modeling or mathematical modeling representing the force affected by the gravity. So we can use modeling to predict behavior of a system. And usually we will use a computer to solve a more complicated or complex model. And modeling is very common in mechanical engineering, such as we can model the dynamics of car absorber. I think you have learned this in automatic control, which we use mass spring damper. We also use modeling to study heat transfer in engine and also modeling fluid dynamics in pipes. Okay, so all of this you have learned in AC automatic control, heat transfer, and fluid dynamics. So in bioengineering, modeling is used to study the behavior of complex physiological system, such as our heart. So our heart has movement of the heart, which is it keeps beating, and then it has blood flow in the heart as well as electrical signals in the heart. So it requires a complex mathematical model to represent the system, and sometimes it can be used to study the interaction between the organs with some external device, such as if you do a surgery, for example. So when you cut a muscle, then there's a force between the knife or pisau, what is it in English, I forgot already, and the muscle. Okay, so there's an interaction between the tissue and some external stuff, okay, external things or device. So why this subject specifically choose bioengineering? So because in biological organ such as our heart, brain, skin, and so on, it requires not only one physics or one physics means one like one system or one modeling. For example, fluid dynamics only or heat transfer only. It requires a combination of various um, physics. So for example, our heart, we have CFD, blood flow, to represent blood flow. We have heart muscle, which can be modeled by solid mechanics. And sometimes we can study the electrical signals propagation and oxygen transport, which requires chemical transport equation. And same for our brain, we have blood flow, chemical transport, and also the tissue mechanics. And in our bone, for example, our bone, we also have solid mechanics, and sometimes our bone can regenerate, especially after it is broken or cracked. Okay, so we can use chemical transport equation. So all of these different modeling must be combined and solved simultaneously. So we no longer cannot use um, solving this model by hand. Okay, we need to use software to solve this because it is complicated and requires to solve it simultaneously. Okay, so this is an example of a modeling of our heart. Tak boleh beli. Boleh beli tak? Okay, so I think later on you can buka this slide and play the video. Okay. Boleh. Okay. Okay, kita stop. Okay, so ada satu lab or group. I think this one is in France. Okay, so they created a complete heart model, and they use I think they use supercomputer. So usually Europe they have a very good facilities for solving finite element model. So usually we will use a supercomputer to solve very complex model, okay, or to make it faster, okay, to solve it faster. But in Malaysia we have supercomputer, we have, okay, but not sure about the application. Okay, so there are other applications. So we can also study vision, okay, how to develop vision prosthesis. So prosthesis is a device that replace the function of an existing organ. Not actually replace, but it depends on whether the organs, the functionality of the organs, whether it is no longer function or maybe the functionality is reduced. So this group, there's a group in Australia, I think in Sydney, that created a prosthesis for vision. Okay, so they implant a small electrodes at the, I think this is retina. Okay, retina. So it replaced the function of the retina, and people can see as usual, but using a device, okay, vision prosthesis. Okay, so there are some other things we can use to study using finite element method. We can study radiation exposure. Okay, I'm not sure about this one. I never tried this. And we can study hepatic tumor ablation. So tumor ablation is a process where we kill a tumor cell or cancer cell in HEPA. HEPA is liver by using ablation. Ablation is by using heat treatment. Okay, so they try to kill the tumoric cell in the liver using heat treatment. So they put some metallic coil or dawai to kill this tumor. And also in the bioengineering, we can study other things like pacemaker, how to develop pacemaker using simulations, and also stent deformation. So we can study the deformation of stent. So stent is a device that we put in blood vessel, usually in blood vessel that is blocked, okay, or being compressed. So we want to reopen the blood vessel using stent. Okay, so let's look at how to the process involved in modeling for bioengineering. Okay, it's the same with finite element method, but we have the law of physics. Okay, so we need to define what law of physics that we want to use. So, for example, if we want to study fluid flow, we use CFD as the law of physics. If we want to study the mechanics, we will use solid mechanics. And if you want to study electrical signals, then we use the electrical model. So all the different physics we will look in this subject maybe after midterm, okay, or before midterm. And then after we decide on the physics, then we set up the model on the software. Okay, sometimes we need to write a code. Sometimes the software already provide you with the code, so you just use the software without the needs to write a code. And then we solve the model. Okay, not software. We solve the model, and then we verify our model whether it's correct or not. And then we get the results, and we do some validation. Maybe compare it with literature or compare it with any data that we have. If it is wrong, then we start we look back at whether we use correct physics or we have set up the model correctly. So let's look at some law of physics. So law of physics is basically a natural phenomena that describe something, okay? Describe a system or behavior. We have fluid dynamics, solid mechanics, and electromagnetics. So in this course, we cover these three things, okay? And if we have enough time, we will try to do combination, okay? And then this law of physics are usually expressed in differential equation. So if you already taken ODE, so the purpose of learning ODE is to do modeling, okay? Very common in mechanical engineering. So we have ODE. So this is an example of DE. Usually we have one differentiation in ODE, dP over dt. And we have partial differential equations. I think you have seen this in ODE, but very briefly. So in PDE, we have this symbol nombor 6 terbalik, okay? But I call it del, okay? Del U over del T. And we have this triangle symbol. Okay, so this triangle symbol represent differentiation of U with respect of space, okay? So we have time, differentiation of time, and also space. So in PDE, we consider the space. Space means if you can imagine a room. So in a room, if we assume there's a person in a room, then the person can move anywhere in the room. So it changes according to the space in the room, and also it changes with time. Okay, as the person move, it can change the position according to time. Okay, so there's a two changes here with time and also with space. But we will look not more into mathematics, but more into the application of PDE. Okay, if we want to go to mathematics, it will be difficult even for me. Okay, so there are different types of model. So we have linear and non-linear. So very common, linear and non-linear, and statics versus dynamics. Whether the model is static or dynamics. Dynamic means it is changes with time. Static usually, it is not changing with time. And some other things like stochastic, deterministic, this is mostly about probability. So this is not covered in our lecture. And continuous versus discrete. So this is more into signal processing and also not covered in our lecture. Usually we will cover the first linear versus non-linear and also the second one, static versus dynamic. Okay, so let's look at an example of how we model something. So we have like this, the common one. that you have seen this maybe in control system and also dynamics. We can model this using mass spring damper, and we get this equation. So this is an example of ODE, okay, because it only change with time. Okay, dx dt. There is no dx over d something else. Okay, it is changes with time only. And the purpose of this model we can use to determine the displacement of the box, okay, or of the mass m. And we derive this using law of motion, Newton's law of motion. And we can also model heat transfer along a rod. Okay, so when we model heat transfer along a rod, I think you probably seen this in heat transfer. Okay, subject heat transfer. So we have this equation del T over del T, small t. So the temperature change with time. And also del squared T over del squared X, del X squared. So the temperature changes with the length of the rod. Okay. So there's a two changes here, change with time and also change with the length. So that's why we use symbol del here, because there are two changes. So this is an example of PDE, and it is used to study temperature distribution along a rod. Okay. Oh, habis dah tiba-tiba. Okay, so there are two types of model. We have ODE and PDE. So for midterm, we will look at how to model ODE using MATLAB. So before we go into learning about MATLAB, learning about solving ODE in MATLAB, if you have MATLAB, you can open it, okay? You can open it, then we can go through basic things about MATLAB. Maybe some of you already know, maybe some of you never used MATLAB before. Okay, so we go to the lecture notes 1B, Introduction to MATLAB. And at the end of this lecture, you should be able to perform basic mathematical calculation using MATLAB and use MATLAB to create a user-defined function. Okay, so if you still remember programming, BMM 1313, 3 years ago, so you use C programming, okay? So the purpose of learning C programming was, to expose you towards basic programming. Basically, C programming is the simplest programming, in which other programming are built upon C programming. Okay, like MATLAB, it use similar command as C programming, but the difference between MATLAB and C programming is that the software is more friendly, okay, or the programming is more friendly compared to C programming. Okay, so let's look at your MATLAB. If you have your MATLAB, I want to show you some basic features in MATLAB. Okay, so sometimes when you open MATLAB, then you might not have this window here, the editor window. Maybe your GUI or layout is like this. You have current folder, command window, and workspace. Sometimes you don't have anything, you only have command window. You can open this kat mana? Oh, layout here. So you can drop down this layout and choose which one you want to open. Okay, so here you can turn off current folder if you don't want to look at your current folder. But I prefer to look at my current folder because I want to know where I save my files. Okay, so whenever you save a file, it's better to save it somewhere that you can access. So firstly, maybe you can open the current folder here, and if you press this button, file with green arrow, you can direct your location, your file save location to wherever you want. Okay, so if for example you want to save in desktop, just choose desktop, but I save it in BMM 4863 folder. Okay, so this is the purpose of current folder. And then the workspace is the place where when you run code, everything or the results will come up in the workspace. So let's say I press something. So let's say I write number 10 here, and then I click enter. So it will give results answer equals 10. So if you look in the workspace, there is a new variable answer here. So variable answer, okay, we have value 10. Okay, so if you double click variable answer, you get variable answer equals 10. Okay, so variable answer is by default. If you key in some number in the command window and press enter, it is by default will be saved in a variable answer. But if you don't want to save it in variable answer, then you need to define your own variable. For example, I define a equals n, for example. So it will be saved in variable a. Okay, so the value is given here. You can double click if you tak confident dengan value given here. Okay, you want to see the value of variable. Okay, so that's the basic things in the command window. So in the command window, you can do some calculations. So for example, you don't know how to calculate 1 plus 1. Okay, macam lupa macam nak kira. So you want a quick calculation, you don't have calculator. So you just write 1 plus 1. And so you get answer equals to. Sometimes you know the answer 1 plus 1, but you don't want the MATLAB to show the answer. So you put semicolon. Okay, you put semicolon at the end. Okay, so it will not show you the answer. Okay, sometimes you feel serabut. Okay, macam banyaknya code kat sini. Nak anak panah ni dekat atas balik. And then dekat workspace ni pun banyak lah. Boleh tak delete? So we have, you can write clear. You just write clear and enter. So clear, we clear the workspace. And you can write CLC to clear the command window. Okay. So you have clear and CLC. Okay, so that's the basic functionality of MATLAB. And there are other things that you can discover on the tabs. Okay. Okay, so go back to the lectures. So MATLAB is a software for doing numerical computation. Okay, so it can solve 2D and 3D. So sometimes in MATLAB you can create a games. Okay, there's a Sudoku game in MATLAB if you search online. Okay, there's also a game like Minesweeper, I think, in MATLAB. Okay, so before we can do some calculation, we need to understand some simple or basic things in MATLAB. So to define a variable, just now I used a big A. So to define a variable, you need to use any letters, big A or small a, or big capital letter or small letter, and then followed by numbers or digits. So you cannot start your variable with a number. So if you start with a number 1AB here, so it will give an error. Okay, so we can try. So ABC equals 1. So we get a variable ABC. So let's say we start with a number 5AB equals 5. So tak boleh, okay? So it will give error, invalid expression. The latest MATLAB, I think they provide this arrow. Arrow here indicates where the error comes from. Okay, I think previous MATLAB 2014 below, they just put an underscore or underline. Okay, so when there's an error in your code, you always look at the first error, okay, the topmost error, and read what they say. Okay, so here it says invalid expression. So either missing multiplication or unbalanced delimiters. So dia beritahu lah ada salah dekat depan ni. Tapi dia tak tahu salah apa. Okay. So MATLAB pun tak pandai. Okay, so that's how you define a variable. So in MATLAB also there is a special variable. So if you have pi, you want to use pi. So dalam calculator we can just spread picit shift and then nama berapa dapat pi. So in MATLAB you just write pi, you get pi. So if you write pi, enter, you get pi 3.1416. Okay, so there are other variables like infinity, EPS, I represents complex number, NaN not a number. Tak selalu guna. Okay, yang selalu guna mungkin pi and I complex number. The others maybe you will encounter maybe during FYP ke. Okay, not sure. Okay, so in MATLAB there is a relational operators. So this operator will be used in if-else statement. Okay, later we will see what is if-else statement. Maybe not today. Good. So there are usually in MATLAB it will use the usual symbols like this symbol represent less than or less than equals or bigger than equals. So if you have dua sama dengan, it is equals to. So to write not equals to, you use this apa simbol ni. So in your laptop ada. Okay. So dalam C programming kita guna tanda seru, tapi dalam MATLAB kita guna tak tahu apa nak panggil. Okay. So in MATLAB also has logical operators, not and or. So not kita guna yang tadi, yang tak tahu nama ni. And then and kita guna simbol and or kita guna simbol slash menegak, okay? Yang tegak, bukan yang sengit, okay? Yang tegak. Okay, so before that, in MATLAB, it used this common symbol as for mathematical operation like star represent multiplication, invalid, and we have slash ke arah kiri for division, and we have plus and minus as usual, and we have power represented by this symbol. Okay, I call it cap. Okay, cap. So let's say if you want to write 2 to the power of 3, so you just write like this, 2 cap 3, so you get 8. Okay, so the common symbol is star, division, slash, plus, minus, and power. Okay, cap to the power. So let's look at what this actually MATLAB is about. So MATLAB is basically solve calculation using matrix. So MATLAB treats all variables as matrix. Okay. So for our purpose, a matrix can be thought as an array. In fact, that is how it is stored. Okay. So if you still remember C programming yang dulu, we learned about array at a very, very end of the course. Okay. Which is very, very not very deep, but very, very kind of brief lah. Okay. About array. But in MATLAB, it basically treated all variables as array. So for example, let's say I define A equals 1 and B equals 2. So if you look at A, double click A, then kita ada table dalam A ni. Table yang kosong, tapi kita ada value 1 at row number 1, column number 1. So it treats value 1 here as an array. Okay, it is saved in an array A. Tapi disebabkan dia satu je nombor, it only has one value. So it is saved at row number 1, column number 1. So we can use MATLAB just like Excel. Okay. So let's say kita nak tambah value kat column number 2. So you just double click here and tulislah 3 for example and click enter. Okay, so you have two values of A. At row number 1, column number 1 equals 1. At row number 1, column number 2 equals 3. Okay, so kat sini dia dah jadi ada kurungan pula kat sini. Okay, so let's look what is this about. So to generate a matrix in MATLAB, so just now I showed you how to generate a scalar, a single value. So you just write x equals 23. So to generate a matrix that has only one row, so kalau nak buat dia satu row saja, kita guna comma. Okay, kita separatekan dia by comma. So if you want to create, let's say x equals 23. So this is a single variable. So let's say you want to create a variable that has one row and many columns. So you can just use comma. Okay, comma to represent a different column. So let's look at y. So y, 1, 2, 3, different column because it is separated by comma, but only has one row. Okay. But if you want to create a matrix that has only one column but many rows, so you use semicolon instead. Okay, so let's say z equals 1, semicolon 2, semicolon 3. Okay, so if you click z, so dia akan tersusun dalam row yang berbeza but the same column. Okay. So you can either, if you macam confused dengan coding, you can just fill in the box, okay, with numbers that you want. If you are macam ada masa boleh fikir dengan coding, so you can just write comma, comma and semicolon. Okay. So we can generate a square matrix yang bentuk persegi or rectangular by combining comma and semicolon at the same time. So for example, this example here, boleh copy tak? Copy. So if you write this in the command, semicolon. So if you look at x, then it is in the form of matrix. Okay. So comma, it separates the numbers by column. Semicolon, it separates the number by row. Okay. So first you separate by column and then by row. Okay, so let's say you want to access a number in a matrix. Okay, so let's say in this example, you want to get the value 5 from variable x. Macam mana dapat value 5 ni? Macam nak baca dia. So you just write x and gives the location. Okay, so the location is at row number 2, column number 2. So you just write x bracket, row number 2, column number 2. Okay, separate by comma, enter. So it gives you the answer 5. Okay, so for example, you want number 6. So write the same thing. So row number 2, column number 3. Okay, so one functionality in MATLAB that is very important, or not important, but that makes you work with MATLAB faster is it saves all the things that you write in command window. Okay, so MATLAB saves everything that you write in command window. You can access the history by simply pressing the upward arrow in your MATLAB in your laptop. So if you press the upward arrow, so you can access all the codes or the calculation that you have written in MATLAB. Okay, so just press the arrow yang ke atas, okay, and you can choose which one you want to calculate balik, okay. So for example, I want x23, then I want to change this code, okay. Let's say pergi 13. So you can simply choose from previous history and modify your code, okay. Okay, so you can also extract submetrics from your big matrix. For example, kita nak dari sini sampai sini, okay, 4 segi ni, 1, 2, 4, 5. Macam mana kita nak keluarkan dia? So you can simply extract. So first, kita nak from row 1 until row number 2. So you just write row 1. So this symbol here, double dot, represent until, okay, sehingga 1 sehingga 2. Okay, from 1 until 2. And then column 1 until column 2. So it extract this matrix here. So let's say you want to extract this matrix 5, 6, 8, 9. So you just write from row number 2 until row number 3. And then from row number 2 and column number 2 until column number 3. Okay, so kita extract dia. Okay, so this is important when you have a very large matrix. Okay, so ni matrix 3 by 3 je, kecil. Sometimes you have 1000 by 1000 matrix. Okay. Okay, ni tadi. Okay, sometimes you can extend a matrix. You can make it bigger. Tak penting kot. And you can do operation on matrix. So for addition, for matrix addition, you must make sure that the matrix has the same size. So for example, X and Y, you must have 2 by 2 matrix and 2 by 2 matrix to allow for addition. So let's say if Z is 1 by 2 matrix, you cannot add with X sebab size dia berbeza. Tapi rasanya ada MATLAB yang baru, saya tak sure yang mana. Dia akan automatic tambah 10.3 ni ke setiap row. Okay. Saya tak sure MATLAB mana. Dia punya functionality, dia dah improve its functionality. But commonly for all MATLAB, you must make sure to add a matrix, it must have the same size. Okay. And for multiplication, so addition just now, same with subtraction. Okay, tambah dan tolak sama. For multiplication, we have 2 types of multiplication. We have matrix multiplication. So multiplication of matrix, the usual multiplication. So to multiply A and B, you must look at the size of the matrix. So for example, in this one, the size of A is okay, so the size of A is 2 by 2 and the size of B is 1 by 2. So to multiply A and B, you must look at the size. Okay, so if you multiply A and B, 2 by 2 multiplied by 1 by 2, you cannot multiply because size dekat ujung ni ialah 2, size A ialah 2, size B ialah 1. So 2 darab 1 tak boleh, tak sama saiz. Tapi kalau kita buat B darab A, so saiz B ialah 2, saiz yang kedua ni. And size A ialah 2 juga. So we can multiply because it's the same size. Okay, so yang ni adalah konsep yang belajar masa form 4 dulu. Okay, kalau ingat lagi lah. So 2 by 2 times 1 by 2 tak boleh sebab 2 dengan 1 ni tak sama. But 1 by 2 times 2 by 2 boleh sebab 2 dengan 2 ni sama. So that's why kita tak boleh kira C equals A times B. Okay, so in MATLAB, we have element-wise multiplication. Element-wise meaning that we multiply element by element. For example, 1 kita nak darab dengan 1, 2 darab dengan 1/2, 3 darab 1/3, 4 darab 1/4. So kita nak dia darab elemen dengan elemen lah. Okay, kita tak nak dia darab secara matrix, kita nak dia darab elemen dengan elemen. So to do that, we put a dot. Okay, so we have another new operation, which is the dot star. Okay, dot represent element wise multiplication. So kalau tak ada dot, it is just a regular matrix multiplication. Okay, so same with division. So if we replace the star with division, we have dot slash. Okay, so here we only have slash. So this is an example of element-wise operation. So element-wise operation only works in multiplication and division. So here we have division, multiplication, and also power operation. Okay, power pun boleh element-wise. So element-wise for power meaning that 1 power of 2, 2 power of 2, 1 power of 2, 3 power of 2. Okay, so setiap elemen ni dia power by 2. And we can also power it by a matrix. So 1 power of 2, 2 power of 2, 1 power of 2, 3 power of 1. Okay, okay, so saya rasa sampai sini saja untuk hari ni. Ini pun dah nak pening dah. So you can try play around with MATLAB. If you are familiar already with things that I shown to you, that's fine. Anggaplah macam ni ilmu tambahan. Okay. Tomorrow we will cover manipulation of functions. Kita akan belajar function, how to build a function, and we will look at one example of how to use MATLAB for plotting and to calculate something. Okay, any question before we end these lectures? Okay, so if you don't have any question, then that's it for today. See you tomorrow, inshallah. Assalamualaikum. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, Doctor.
Thank you, Doctor.
Thank you, sir.
Thank you,
Thank
sir.
you, Doctor.